A space mission on duty, like an Earth observation satellite gathering data at around 660-kilometer altitude, normally offloads the acquired data through a geo-intersatellite data relay system and its polar gateways upon revisit, meaning non-real-time tasking. However, if we configure the space mission with a commercial off-the-shelf ground terminal that can connect to already existing satellite internet providers in medium and low Earth orbit like O3b, OneWeb, and Starlink, it can not only offload on demand and real time, but also reduce the mission's costs. O3b mPOWER is a MEO constellation consisting of 60 satellites orbiting along the equatorial plane in green, and two additional planes that are inclined 70 degrees, colored red and yellow. This constellation orbits at 8,062 kilometers, and if the space mission were going to connect to the network through O3b mPOWER, it would have permanent access satisfaction without discontinuity throughout the day of work, thanks to the relative distance of hundreds of kilometers between low Earth and medium Earth orbit satellites. A LEO space mission would always be in the visibility cone of O3b mPOWER. Now, if the same Earth observation mission decides to connect through OneWeb mega-constellation consisting of 630 satellites in its phase 1, with 100 orbital planes that pass the poles at 1,200 kilometers, it would still be satisfied 96 to 99% of the time, yet with periodic interruptions that mostly occur as the space mission passes the equator, where the constellation architecture is not as densely populated as the poles are. Let's consider a very low Earth orbit space mission at 300 kilometer altitude, who is interested in using Starlink as its satellite internet provider. Starlink orbits in range of 540 to 570 kilometers above the Earth. 4,408 satellites with highly orchestrated orbits covering densely latitude range of minus 53 degrees to plus 53 degrees of Earth's surface, and less enthusiastically the polar regions. In this case, the VLEO mission would enjoy continuous access only 86% of the time, given their close proximity in altitude and polar coverage gaps of this mega-constellation. All in all, using ground terminals in space and connecting through commercial satellite internet providers for space missions has been found practical and potentially very cool as well. Thanks for watching.